Welcome. In this session, we're going to show how you can protect your business from cryptojacking using Panoptica or Cisco Cloud Application Security. Cryptojacking is a very popular form of attack, and we're going to discuss in a moment just how popular it is. But first, what we're going to do is analyze a concrete case example that's been in the news. Not that we're picking on the organization, but rather just using it as an example, because really these vectors are very, very common. So let's begin our analysis of that, see how common cryptojacking is, and then finally how we can protect ourselves from it. So we're going to use this example that's been reported in the news and analyzed forensically. It was very well documented. It was on Tesla. But again, by no means is this an isolated incident, but rather it's a very common scenario, as we'll soon see. So first of all, what has happened is that they had a publicly exposed Kubernetes application programming interface API server. Basically, that's the control plane to your Kubernetes interface. Generally, it's a best practice to lock that down and to restrict access to it to an IP address range. But in this case, it was publicly available and open. And then when they were able to gain access to it, they were able to discover embedded secrets in some Kubernetes objects. This is also a very common occurrence. We see that sometimes developers, because they're tasked with rapid application development, they sometimes take shortcuts and embed credentials like usernames and passwords as environment variables rather than using the longer but more secure approach of using Kubernetes secrets. Anyway, so they were able to go through the various objects. They found some of these credentials and then they logged in using those credentials. Now this allowed them to escalate their privileges, and they had administrative capabilities, which then led them to launch their crypto mining scripts and then discover and poke around further and gain further access. They even came across an S3 bucket, an Amazon Simple Storage Service bucket that has some proprietary information in it, but there was no record of them actually pursuing anything with it. It's not like they encrypted it or held it for ransomware or anything like that, but rather their focus was on their crypto mining. It's very classic. It's a very attractive attack because the attacker starts making money as soon as they launch their scripts. There's no extended or protracted negotiation with the customer saying, I am going to hold this for ransom or I'm going to encrypt everything or whatever the case may be, as in some other types of attacks. But here they're making money as soon as they launch their scripts, and they want to do this as long as possible and unobtrusively as possible so that the person, the person being attacked or organization being attacked, they may not even notice for several months, usually when they get their cloud provider bills. Okay, now, again, I made the point this is not an isolated incident. So how common is this type of attack? What do you think? Well, in 2022, I'll give you a frame of reference. In 2022, there was 139 million cryptojacking attacks. Any guesses on how many last year in 2023? There was actually over 1 billion cryptojacking attacks. It's staggering to recognize how big and how pervasive this form of attack has become. That's nearly 3 million attacks every single day on average last year. Now, are these attack vectors that we've just discussed very unusual, or was this, a strange case? No, it's actually very common. We see that according to some reports, 82%, 4 out of 5 customers have exactly that same publicly exposed Kubernetes API server, and about 1 in 3 customers also have or 1 in 3 organizations have embedded passwords or embedded secrets in their cloud services. Again, it's a very common occurrence. It's just a function of developers moving very quickly and not always tidying up or sometimes taking some shortcuts. Okay, so that all being said, given that this is very, very common, very relevant, how can we protect ourselves? Why don't we take a look at how Panoptica can make this very quick and very easy, both for attacks that we've seen, as well as evolving and mutating forms of cryptojacking attacks. Okay, so let's now take a look at how we can protect ourselves from cryptojacking using Panoptica, or Cisco Cloud Application Security. Initially, I'm actually going to do things a long way to show a unique and important feature of Panoptica that really speeds up the process. Let's say that I read about this attack and then I recognize that they came in through an API server that was exposed. I might go to my security posture over here and just do a natural language search for API server and then see, oh yes, lo and behold, I have exactly the same vulnerability in my environment in at least one endpoint. I got a public API server that's accessible. This is an open worldwide application security project known top 10 misconfiguration. It's recommended not to do this. And I can see the specific asset. I can even go through remediation. It tells me what I need to do. And if I want, I can even click on the CLI to give me code to do it, create a ticket and all that lovely stuff. Then I could perhaps do the same thing and say, okay, well, and then not only did they exploit that, but they found secrets in the environment. And I click on secret exposure and then, unsurprisingly, actually, I found the same thing in my environment. Again, 36% of organizations have this. It's very common. Now, I could do that one by one for all the different elements that combined to contribute to the attack, to enable the attack, but we're already doing that for you. This is a huge advantage of our attack path analysis. So rather than looking at individual vulnerabilities, for instance, I have nearly 2,000 software vulnerabilities in this environment, 20 identity risks that could be exploited for privilege escalation, 120 nearly configuration risks that I need to take a look at, and 91 exposed secrets. Now, I could spend all day going after these one by one, but really what I want to do is look at things through the lens of an attacker, to combine all these contextually, which we do using a graph database. And then I realize, okay, there's 4 paths that an attacker can take and exploit a vector and exploit various lateral movement opportunities within my environment and then really cause a lot of damage to it. So for instance, this particular path is very similar to the one that we just analyzed. We have a publicly exposed AWS EC2 instance. In addition to that, I've got a known vulnerability, a software vulnerability, a common vulnerability exposure. I also have some configuration risks and a risky identity and access management role. So I got like a perfect storm going on here. A lot of similar elements that we just analyzed in our case example. But more than this, it's not just calling out to me what are the risks and the combination that can lead to me being taken over in a crypto mine, but I have the ability here to solve the problem. So for instance, I click on remediation. It tells me what I need to do to solve the network exposure elements, the workload exposure elements, the identity risks, etc. And I can get all of this code generated for me in my syntax of choice, maybe CLI console, code snippet, or Terraform. Let's say that I prefer Terraform. I click on that, and then it automatically then generates all the syntax in Terraform to deal with my specific vulnerability in my specific environment, exactly what I need to do, and then I've got it all there, and I can go from there and copy it and log it to a ticket, however I want to architect my workflow from there. Okay, now these are examples for attacks we've already seen, but these attacks mutate and evolve all the time. So how do we protect ourselves against the next generation or the next evolution or mutation of these attacks? Well, we have a smart CDR, cloud detection and response feature, also in Panoptica. So what this is doing is continually monitoring our environment for anomalies and to see what's going on, and then it's trying to identify the intent of these anomalies and see what is the overall purpose of them. For instance, we have a data destruction attack that we've just recently analyzed, one that we haven't seen before. And over here, look at this. We have a high severity crypto mining attack. It's just completed just a few minutes ago. And what we're doing here is we're analyzing, like I said, all these individual anomalous activities and then trying to use AI to ascertain and discern the intent behind them. We see that they're trying to access our Etsy password files. They're spawning a new process. It's trying to list environment variables, so that's very much an active discovery, and so on and so forth as we're going through the workflow. And we see this particular attack it's got 11 individual steps. And then we get to the point at step 9 when we're actually executing a crypto miner script. And then on top of that, it's doing some defense evasion. It's moving the directory where the script is executing from to try and evade attention. So very, very common elements of these type of attacks. But I really want to stress this is a new mutation of a cryptojacking attack, one that we've never seen before. And we've analyzed it and reported on it and forensically got all the data around it within just a few minutes of it occurring, whereas the industry average of doing this manually is about 200 days. So there you go. So whether we've already seen the cryptojacking attack and have signatures for it, very quick and easy using attack path analysis, but then we're not left there. For new attacks and new mutations, we can use smart CDR, that is cloud detection and response, in Panoptica, and continue to protect ourselves as these attacks mutate and evolve. Okay, there you have it. Very quick and easy to protect ourselves against cryptojacking attacks, whether we already have the attack signatures or they're completely new ones that we've never seen before. So what next? Well, let's get started with using Panoptica. Go to panoptica.app. You can see videos, read case studies or blogs, or most importantly, you can sign up and start using Panoptica for free. In a cluster, 15 nodes, get up and running. There's no time limit, no feature limit. We want people to take it for an extended test drive to really see how quickly and easily you can add value to your organization, improve your security posture against cryptojacking and many other types of cloud application attacks. Thanks for taking the time to watch this video.